Hello again, everyone. Today we are going to talk about graphing systems of linear inequalities. So just like graphing one inequality, now when we have systems, it's similar to what we've been doing with finding that solution point, except there will be a range of solutions. So check this out. Make sure you understand that. It is also on your notes. So let's look at this. They got it from problem 1 on the Pearson module. So hopefully you are in tandem working through the Pearson module and you've checked out slides 1 and 2. Slide 3 was kind of pointless, but slide 4 here we have y is greater than or equal to negative x plus 5. And then this line, we want to get into the y equals form before we can do anything with it or before we can put it on the graph. I always think that's easiest, at least, because the y equals form tells me essentially everything. So to get that into the y equals form, there's just one step we need to do, which you are correct. We need to add 3x to both sides. And then it's always good to write your x first. So then we can say that that becomes y is less than or equal to the positive 3x that's now on that side minus 4. So I now know the slope here being negative 1 and the slope here being 3 and the y-intercept being 5 and negative 4. So go ahead, make your x and y axes and then go ahead and try to draw those lines. And then if y is less than or equal to this graph, but greater than or equal to that line, see where you think the shading would happen at. Pause the video now and try this. Here we go, guys. Because my drawing on the Smart Slate is oh so great, here are your two functions, and so here is our y equals the negative x plus 5. We have a slope of negative 1 there. Here is our y equals 3x minus 4. We have a steep slope here. So if we're less than or equal to, and we're or equal to both of them, so both lines are solid, we're less than the red line, so we have to be below the red line, but then we're greater than or equal to the blue line, so we have to be above that. So actually this region right here is what shows both of them, and it's a little hard to tell with the coloring on here. But this would be shaded really dark because we'd be shaded above the blue line and shaded to the right or below the red line. Go ahead down here in these practices then and try 1 and 2 on your own. You can see how I've already started in number 1 trying to get it to the y equals form for that second equation. So pause the video, try both of those, then come back to check out the solution. Alright, so I've got both lines graphed here. My green line is greater than or equal to, so that is a solid line and I would shade above it, but I just realized a mistake I made. Y is less than here, the 2x plus 4. I made a solid line. That line should be dashed, so make sure that you have that line dashed. So because y is less than for the blue, we can shade below the blue line. And then because y is greater than, we would shade above the green line. So in the area that is really the solution for the system is the area that is shaded in both colors. You can go ahead and do 2 on your own, or you can skip it if you're feeling confident at this point. I am going to move on in the notes and keep trucking through this material. To check whether a point is a solution for a given system, you have to check if the x and the y sub in for both inequalities and make them both true. So hopefully you work through the Pearson module to see that. Try that for 3 and 4. So in checking this first equation here, we see that we plug in the 12 for the y, and that's greater than 2 times 2 plus 4. Well, 2 times 2 is 4, so we know my right side would be 8, and 12 is larger than 8, so that checks out. Coming down to my bottom inequality, we plug in the 12 for the y, the 2 here, so we get 12 is greater than 3 times 2 plus 7. This, in fact, is not true, so this is not a solution point because this would be 13. Go ahead and try number 4 if you have not yet. All right, so if we plug in this x and y, so my x is 8 and my y is 2. So when I plug that in, 3 times 8 becomes 24. This becomes minus a 4 is less than or equal to 17. 24 minus 4 is 20. Is that less than or equal to 17? I don't think so. So that one doesn't work out. Just for fun, let's come down and check this one. 0.3 times 8 would be 2.4, then plus 8 would be greater than 9. That is in fact true, but up here, this makes it all get messed up, so that is not a solution point either. Hopefully you've worked through Pearson problem 2 for this lesson and made it to the got it. So now to write for the system of inequalities, I'm going to color code this. I'm going to start with my blue line. So the first thing I always look at is what's the y-intercept. So here my y-intercept is 1, so I know that I'm going to have a blue equation. that is y compared somehow at the end I will have a +1, and I'm going to fill it in as I go. My area that I see shaded is below it, so I know that's going to show y is less than. My line is solid, so I know that shows less than or equal to. My slope, if I look at my rise over my run, my slope there is 1/2, and that goes with the x. So there is my blue line. Go ahead and try the red line on your own. Pause the video and write out what you think is for the red line, and then come back and see us for the answer. So the red line has the same y-intercept, so I'm going to start by saying y and my 1 again. And then it's dashed, so I know that it will not have the or equal. It's below the line, so it's less than. And then I check my slope. My rise is 1 as my run is 2, but remember that rise was negative, so it's a negative 1/2 x. And that is the system that is shown by these inequalities. So now ponder for just a second this question here in B. This point where the lines intersect, is that point a solution point of the graph? Would this point where x equals 0 and y equals 1, would that be a solution? Make your guess, yes or no? The actual answer is no. And if you can't think of why, take a moment, try to figure out why. It is because this line is dashed, it is not included, so that point is not a solution for the red line, and therefore it is not a solution for the system. Go ahead, pause the video, and try to write the systems for 5, 6, and 7 here. Should be fairly quick because you're just identifying the y-intercept and the slope, and where it's being shaded, and if the line is solid or dashed. So for number 5, we have a y-intercept of 0, so that does nothing for me. And then I have a slope. My run is 3 as my rise is -1, so I have a -1/3 slope. It is dashed, so it's just y is less than -1/3 x. And then we look at the same thing with the y-intercept and the slope for my red line, and we get y is less than or equal to x plus 2. Pause the video and do 6 and 7. If you've not done them yet, please pause and make sure that you're able to do this on your own. So here are the other systems of inequalities for 6 and 7. On 6, you can remember the VUX. The vertical lines use x, and that is your x is less than 1. Over here, you can remember your HOI. The horizontal uses the y, so y is greater than or equal to 2, and you can see everything else to check your work. All right, so I'm going to be drawing this graph really quickly, so please ignore the details. So you want to build a fence for a dog run, like a dog area. You want the run to be at least 10 feet wide and at most 50 feet long. So I actually now realize that I made one slight error. This should be a 10. So again, please ignore these details. So if this is the width and this is the length, don't count these boxes. I know that the width needs to be 10 feet or above. The length needs to be at most 50, so 50 feet or below. And I know that I only have 126 feet of fencing. So I can't make it be 50 feet long and 10 feet wide in both places, because that won't give me I could make it just 50 feet long and 10 feet wide, but that, I want to talk about what are the possibilities that I have. So go ahead and sketch what you think the shaded part of this graph that would show me where, what I can actually make the lengths and the widths. If you haven't done it yet, try the graph on your own because I'm about to show it to you, and here it is. You have two options here, are 20 feet and up, are 50 feet and under, but then do you think I shade above this diagonal line or below this diagonal line? Now let's look at what this diagonal line is telling me. If my width was 62 or 63 probably, so that it was 126 feet of fencing, this is the line of the fencing that I have. So if I did not have a length to my dog run, if it was only 63 feet wide and had no length, which would not make sense, then I have a width. So my width gets more and more and more, and as my width gets more, my length has to get less, or as my width gets less, my length gets more, But still, I only have this much fencing, so this area right here, in fact, your correct answer is A. This area is what represents the possibilities for the lengths of the fence. And the lines are solid because I could choose a point on that line and it would work for me. So take a moment, pause, and try this problem. Suppose that you have a job mowing lawns that pays $12 an hour. You also have a job at a clothing store that pays you $10 an hour. You need to earn at least, so that means $350 or more each week. And you know that you have to work a minimum of 10 hours per week at the clothing store. So it doesn't matter how many hours you have mowing lawns apparently, but you have to work at the clothing store 10 hours or more. Probably they'll fire you if you work any less. So pause the video and try to draw this graph. What you want to think about is the minimum of 10 hours per week at the clothing store. That will be either a horizontal or vertical line. That is a boundary. We will have the $12 per hour and the $10 per hour going into making my pay of at least $350. So try this on your own. Come back in a minute for help. Pause the video. So again, it's much easier for me to show it to you than try to fight with my SmartPad. So over here we have the graph. So if my x-axis is hours spent mowing and my y-axis is hours spent working at the clothing store, I know that my y is bounded to be 10 or above. So my region above that line is all that counts. Then I know that I need to make $350. So if this is at the clothing store, well, the clothing store pays me, if we check our information back here, $10 an hour. So if I'm working at the clothing store for 35 hours at $10 an hour, that point right there tells me that I've made $350. So then as I work less at the clothing store, I have to work more mowing. So I work more and more mowing. Now this is the line that then bounds the fact that I can work no more than 35 hours per week. So we didn't have that highlighted, but this whole no more than 35 hours, that's really important because that's my upper boundary. If I pull this back up, that's this line on top, that upper boundary for saying I can only work in this small little slice right here. I'm really quite constrained. Say if I work 10 hours mowing lawns, then I only have a small range of what I can work at the clothing store. It's probably between like 26 and looks to be about 30. And we could figure out the exact values by plugging them in. But here would be the two equations that we derive. That my $12 an hour mowing, my $10 an hour clothing store needs to make me more than or equal to $350. And then my time spent mowing and my time spent at the clothing store has to be less than or equal to 35. And that my time spent at the clothing store has to be greater than or equal to 10 hours. So it's all about setting up all three of the equations and making sure that we know how to graph them and where we're shading for both of them. So if we look at 22, trying to find all solutions that are in quadrant 3. Well, to talk about that, we'd need to talk about where is quadrant 3 again. Most people can remember that the quadrant where the positive x and positive y, that makes our quadrant 1. But then what throws some people off is we go counterclockwise. This becomes quadrant 2. This becomes quadrant 3, and this is our quadrant 4. So quadrant 3 down here is where my x is negative and my y is also negative. So if we were to write inequalities to represent that, go ahead and try for a moment, see what your x and y inequalities would be. So if it needs to be in the quadrant and not on the axis, then my x's would all be less than 0. And my y's would all be less than 0 also, because my x's being less than 0 shades all of this out here. And then my y's being less than 0 shades all of this. So the overlap then becomes that quadrant 3. Go ahead and try 23 where there are no solutions. And on 23, there are a ton of options. So here, I just went ahead and made something that the ranges do not have any chance of coming close to each other because I know that my lines are both parallel. This one has a positive y-intercept of 5, so it'll have an upward slope and shade everything above it because y is greater than. So then my other inequality is y is less than or equal to x minus 3. So now the y-intercept is way below, and the lines are parallel, and I would shade below, and the line will be included, but there's actually a gap between the two lines, so there's no point that will fall into both of these to make both of them true. I'm out of time, so go ahead. We can discuss the last problem here in class if you'd like, but please make sure you've worked through all of Pearson and you've done your homework. Choose either odds or evens to take care of, and let me know if you have any issues. Thanks, and have a great day.